Hi, and welcome to the second extension video on adding and subtracting algebraic fractions, this time with different denominators. So by the end of this video, we're going to hope that you can add and subtract some of these algebraic fractions when the number on the bottom is not the same. So let's have a look at how to do that with some examples. If the denominators are different in our algebraic fractions, what we need to do is to write some equivalent fractions with a common denominator, and then we can add or subtract. Let's take a look at the example on the left-hand side, the numerical example, 1/3 plus 2/5. Now I can't just add the numerators and denominators together to get 3/8 because that's not how fractions work. What I need is a common denominator. Now that 1/3 and that 2/5 require a common denominator of 15. And I know that it's 15 because 3 lots of 5 is going to be 15. Really what I'm looking for is a number that both 3 and 5 go into. So that 1/3, because I multiply the 3 by 5 to get 15, I also multiply the 1 by 5 to get 5/15. So 1/3 and 5/15 are exactly the same fraction. All I did was multiply the numerator and denominator of 1/3 by 5. Now for my second fraction, 2/5, I need to multiply both the numerator and denominator by 3, so it will turn into an equivalent fraction with 15ths in its denominator. So to multiply 2/5 by 3/3, I get 6/15. Can you see how 2/5 when multiplying the numerator and denominator by 3 gives me 6/15? Now I've got a question that is exactly the same as the original question, except I'm talking in terms of 15ths now. Now I'm just going to add my numerators together and get an answer with a common denominator of 15. Final answer, 11/15. This same concept goes with algebraic fractions as well. So let's look at the right hand side. We're going to be trying to do 3x/8 plus x/2. They clearly don't have a common denominator. So what number can you see that both 8 and 2 will go into so that we can change these fractions so they have the same number in the bottom, in the denominator? Well, if you said 16, you'd be absolutely correct because 8 times 2 is 16. But really, there is a lower number than 16 that both 8 and 2 will go into. Can you see it, or did you get it the first time? That number is 8. 8 will go into 8 and 2 will go into 8 as well. So what we want to do is get a common denominator of 8. Now this means that our first fraction, 3x/18, will not change. It's already in terms of 8s. But that second fraction needs to be multiplied top and bottom by 4 so that my x/2 becomes 4x/8. I now have a common denominator of 8, and this question is exactly the same as my original question. Now I'm just going to add my numerators together and get my denominator in terms of 8s, getting an answer of 7x/8. What I want to do now is to get you to try some for yourself. Here I have 3 examples, all with different denominators. I'd like you to pause the video and try and work them out for yourself, either with a piece of paper or in your books. Okay, I hope you paused the video because I'm going to go through them right now. 2p/3 plus p/5. I want a common denominator of 15. 3 lots of 5 is 15. So I'm going to be changing my 2p/3 into 10p/15 because I multiplied top and bottom by 5. And for my second fraction, I need to multiply top and bottom by 3. So I get 3p/15. Adding them together gives me 13p/15. Trying my second question, 6m/7 minus 2m/3, looking for a common denominator, I need to multiply the 7 by 3 to get 21. So my common denominator will be 21. Now that first fraction needs to be multiplied by 3, both top and bottom. So 6m times 3 is 18m. That second fraction needs to be multiplied by 7. So 2m times 7 gives me 14m. Now I can subtract. 18m minus 14m is 4m. So my final answer is 4m/21. Finally, question number 3. I'm looking for a common denominator, and 5 times 2 will give me 10. Now what I need to do is multiply my first fraction by 2 to get 2a/10, and multiply my second fraction by 5 to get 5b/10. When I add them together, I get 2a plus 5b/10. Do you notice how my answer is not 7ab/10 because you can't add unlike terms? These are A's and these are B's. It's apples and bananas. I hope you got those, and if you didn't, use these examples to help you get through your exercise. So here's what I'd like you to pause and summarize. Start off with our example about where we need common denominators first, and then write down the 3 examples that you tried for yourself, this time with the correct answers if you didn't get them the first time. And that's it. Hopefully now you understand how to add and subtract algebraic fractions with different denominators, and if you don't, you can always ask questions in class tomorrow. Good luck.